Okay, so since the first part of this is linear, let me give you an example of what I mean by linear equations and why I'm not really going to go over it, because if you guys don't know this, you shouldn't even be in here. Like, for example, they're going to give you a problem like this. So see, I shouldn't have to teach you how to do that because you already know, but we'll do it real fast just so.
I just answered number 3 on the homework. Roll it.
The only thing that you might need a reminder of, and I will tell you one in just a second.
Is it the find the restrictions?
We're going to talk about that in just a second when we get to the rational side of things. But so x equals 2. So that was so easy, no big deal. Okay, so what happens, this is just a quick reminder, what happens if I have a linear equation, and I don't have one in front of me so that I can't actually show you an example, but let's just, oh yeah, I do. Here I do. Real quick, okay, so starts out the same. 3x times x plus 5 equals 3. Okay, so quick reminder, if I start doing this problem, and this happens, when I go to solve this, my x's completely cancel and I end up with 15 equals 3.
It's not like a real, or it's
undefined.
No, there's a word.
If it ends up 15 equals 3, there's not a fancy word for this one. If it ends up 15 equals 3, it's no solution. Because 15 doesn't equal 3.
Yeah.
However, if you get one like this, let's see. And I solve this one out. So I'm combining like terms, 5x and minus 2x is 3x, 5 and 10 is 15. Okay, so I have 3x plus 15 equals 3x plus 15. Which if you don't recognize right now, the left side completely equals the right side. But if you didn't even notice that and you kept going, and so you tried to subtract minus 3x from both sides, my 3x's completely cancel and I end up with 15 equals 15. 15 does equal 15. This is called an identity. Because what's on the left equals what's on the right. But the answer is all real numbers. And I know on the computer I haven't actually worked the homework, but it tells you on, I think, every linear problem what to put if the answer is all real numbers and what to put if the answer is no solution. But this is the big difference. If what's on the left doesn't equal what's on the right, it's no solution. If they equal each other, it's all real. If it's x equals, that's the answer. So, okay, so that's linear. Told you it's easy. Okay, so now rational equations. We already reviewed rational expressions, simplifying them, adding, subtracting, multiplying them. So solving them, it's going to feel like we've already done this. But the only thing we didn't talk about the other day when we did it was restrictions. So, if you have rational expressions, for example, that look like this. Also, on these assignments, be careful about what it's asking you for, because sometimes it's not even asking you to solve it. So make sure you read the instructions. Like one of these, they're not going to even ask you to solve. They're going to say, what are the restrictions? Well, what causes these things to have restrictions in the first place?
For it to equal what's 0.
Right, the bottom can't equal 0. So the restrictions are whatever would cause that to happen. So in this case, b cannot be -6. Because if I put a -6 right here, that would be 0. And that won't work. b cannot be 1. It can't be either of those things because neither of the denominators can go to 0. So the restrictions are -6 and 1. That's it. So make sure you're reading what they're asking for, because if all they're asking for is restrictions, there's no point in solving that equation. Now we find the restrictions so that when we solve the equations, we know if the equation is a real, if the answer is a real solution. We'll do one in a minute so you can see what it looks like. Okay, so let's do a linear problem with fractions that's not rational yet. It's just a linear problem that has fractions in it. And I'll explain the difference if you don't know. Okay, so this is not considered a rational equation because it has no restrictions, because it has no variables in the denominator. These variables that are written next to the fraction are actually on top. So that's usually the first thing I do is rewrite them on top because I like it better that way. It's easier to look at. I think it makes it easier to solve. Now you could go through, there's several things you could do. You could go through and find a common denominator and add and do all that. Or you can clear fractions. You can clear fractions one at a time, or you can clear fractions multiples at a time. It doesn't matter. So if I was going to clear all the fractions at once, it's essentially the same thing as finding a common denominator. If you want to clear just one side, you could do that, which would mean on this side I would multiply by 6. Which means if you multiply this by 6 and multiply that by 6, then you clear 5. It doesn't matter to me how you choose to do it. Let's just, for the sake of all doing it together, let's multiply by what would be the common denominator. So between 2, 3, and 5, what's the common denominator? Anybody know?
$30.
30. So I'm going to multiply both sides by 30. When you do, you have to multiply every piece by 30. Now, long way would be to actually multiply the tops and then divide, or I think it's easier to divide first. 30 divided by 2 is 15, 15 times 3 is 45. 30 divided by 3 is 10, 10 times 2 is 20. 30 divided by 5 is 6, 6 times y is 6y. And now you're just solving an equation. And subtract 6y from both sides, add 20, and I get y equals 20 over 39. Simplified if you can, it doesn't. Simplified. So that's it. Everybody good? Did you know? Sorta. Alright, let's do one that is a rational equal. This is just like what we're doing the other day, so it should be easy enough. Okay, so in order to solve this, we're going to have to find a common denominator, because when you add fractions, you have to have a common denominator. In order to have a common denominator, I have to know what pieces are in my denominator, so I'm going to have to factor anything that is not already factored. My first fraction is already completely factored. And my second factors as x plus 3, x minus 1. This is exactly like what we were doing the other day. LCD box. Go one fraction at a time. If it's in the fraction, it has to be in the LCD box. So my first fraction has an x plus 3 that has to go into the box. My second fraction has an x plus 3. That's already in the box. So you don't have to put it again because it's already in there. But x minus 1 is not. That one. Now I go back. My next one only has a denominator of 1, so I don't even have to worry about that. So now I go back to each fraction and check and find out what it's missing. So my first fraction is missing x minus 1. So I put that on bottom. I also have to put it on top. My second fraction is not missing anything. My answer is missing both pieces from the box. So I'm going to have to multiply both pieces. Now, as soon as you've made sure that all your fractions have, the common denominator, so my first piece has what's in the LCD box, my second piece has what's in the LCD box, my answer has what's in the LCD box. Once they all have what's in your LCD box, you do not need the denominators anymore. You're only concerned with the top. So now I have a linear problem. Actually, it's a quadratic problem. It's going to be a linear problem. And I can work that out. So, FOIL. Bless you. My left-hand side simplifies. Alright, I'm going to subtract x squared from both sides. When I do those go away. I subtract x from the left. Okay, so I solved the whole thing out, and I got x equals 2. You must check rational expressions and make sure that 2 is not one of your restrictions. So go to your LCD box and check what would be restrictions. So this can't be negative 3, so I'm good. This one can't be 1, so you're good. What if I had solved this whole thing and it had come out to be negative 3? And I go up to my restrictions and go, oh wait, negative 3 is a restriction. Then what do you put?
No solution.
No solution. Because you found a solution, but it's extraneous. It's extra. It didn't really work. Everybody okay? Okay. Last thing. These are for some reason are a struggle. You guys have been doing these since 9th grade, I promise, but they're always a struggle. Don't know why. These are called literal equations, and it's when you don't have numbers, only letters. And they're formulas. Sometimes they're formulas you know, sometimes they're formulas you don't know. This one's one you know. You may not have memorized, but you do know it. This is a formula for turning Celsius into Fahrenheit. And what literal equations are, it's how we rearrange an equation to solve for the piece we need. So in this case, they give you the equation. Right now, it's Celsius for Fahrenheit, but they want us to find the one that's Fahrenheit for Celsius. So they asked us to solve for C. All that means, when it says solve for C, is to isolate this piece, get it by itself. So it's just like regular algebra, you do everything you would do to get C by itself. So what do you do first? Minus 32. Okay, so now I have F minus 32 equals 9/5 C. Now, normally, because I like people to understand exactly what I'm doing, I would probably clear this fraction by multiplying both sides by 5. And then I would be left with 9C over here, and I would divide by 9. But because I know this formula and I know how they want it to look, I'm going to do that all in one step. So instead of multiplying first and then dividing, I'm just going to multiply by the reciprocal. Everybody understands that's the same thing, right? So if I multiply by 5/9, over here, my 5's cancel, my 9's cancel. And I'm left with 5/9, F minus 32, which is the formula for turning Fahrenheit into Celsius. You can distribute the 5/9 through also if you wanted to. I think the computer will count either one and then right, because you see it written both ways. Okay, so let me give you another one. Let's see. Okay. A surface area of a cylinder. Okay, so they want us to solve for h, which just means get h by itself. So I need to get rid of everything that is with the h. What do I do first?
Minus 2 pi r squared.
Yes. Okay, I'm still just trying to get h by itself. So I need to get rid of that pi r squared. What now?
Can you just divide that?
We can just divide by pi r squared. If I divide this by pi r squared, I'm going to do it this way because since I have a pi r squared here, you have to divide everything by pi r squared. Instead of doing it all in one fell swoop, I'm just going to divide it individually. It's the same thing, but nicely this piece will cancel. So I end up with a over pi r squared minus 2 equals h. That's it. Okay, let me give you another one, because this one has just kind of a little trick. This is an accumulated interest problem. And they ask you to solve for p. Now, here's the problem with this one. I would love to solve for p, get p by itself, but there's two of them. And they won't combine because they're not like terms, because this one has an RT and this one doesn't. So the only thing you can do is factor out a GCF. See, they both have a p. They have that in common. So factor it out. Undistribute p. So that means I have a p and then in parentheses. Now what would have to be here in order to get a p when I multiply? 1 plus RT. Now all we have to do is get this p by itself. You can divide all of this at one time. So I get a over 1 plus RT. One more, just to practice. Alright. This has something to do with polynomial solutions. Take a second and try it. together. So I'm going to subtract FP from one side. So I end up with PQ minus FP equals FQ. Now again, I'm in the same boat that I was in a minute ago. I have two P's. So I'm going to factor out a P. That leaves me Q minus F. And then you can just divide by Q minus F. And that's it. So I got P equals FQ over Q minus F. That's it. Okay? Those are probably, now, the assignment, it looks longer because it's 26 questions, but the very beginning is linear and pretty simple. And then it gets into rationals and they're going to be a little tougher. So